Hey everyone, we're gonna focus today on explaining how to create a liquidity pool on Delphi. Just to start things off, just wanted to introduce the team here. I'm Andrew again, mainly focusing with product management, design, and marketing. Want to go around?
Yeah, I'm Alex Lewis. I'm the lead dev at Delphi and the main author of the Solidity smart contracts for the DEX.
And I'm Nathan, Solidity expert and Ethereum developer.
Yep. We also have a remote front end team in Asia as well, but the contract and Solidity work and main architecture decisions and strategic decisions is this core team here. So if you've seen the last video, we explained how fractionalized art works. This is Sven's piece, Sven Iberine, and we explained how the bonding curve works. So it appreciates linearly according to how many tokens are bought. And the other video goes into that in depth, and IDXM is the same thing. It has linear price appreciation. You can see the bonding curve. You can see trading analytics are both on BLEP. So how to actually create a market on Delphi, we're going to go over. So it's almost exact UI parity to Uniswap, but the algorithm and the math to how the price is determined is unique. But anyway, you click create market. I'm just going to create a market for a token that's in my wallet. It's Frax, even though ideally, you should be creating token markets for newly minted tokens for new projects and art tokens and other ERC20s. But I'm just using Frax as an example. So so this is where you design like the linear price appreciation rate. There's slope, and what you're seeing here is the formula y equals mx. And so this is just a spreadsheet example, but it's a linear formula y equals mx, and here you're basically inputting that linear slope value for how much you want the token price to appreciate by with and the front end, by the way, multiplies the actual slope value by 1,000,000. So if you want a slope of 0.25, y equals 0.25x, you actually have to multiply it by 1,000,000 and then input that value into the site. And we just did this because the numbers that we're working with are small, and it makes sense to kind of make them whole numbers as opposed to like very small fractions of a single digit.
And to clarify, that is necessary in Solidity since we're dealing with integer math. To take a fraction, our slope is specified by the numerator, which is a fraction of 1 million.
Yep. And so you scroll down below and you can see a table that breaks down the same information that you see in the chart, but just in a different format. And you can export this table in the form of a CSV file if you wish to, and it exports basically the same data just in a CSV file. You can understand the price action and have that data in just a different format. So let's just say we set the slope to this amount. I mean, what this means is basically this is the price of each token, and this is how many tokens are bought. And so you go to the next step. Well, we could talk a bit about how this works. Lex, you wanna?
Yeah, this is important to note here. So everyone's familiar with the price function y equals supply x. And every function that the contract uses is derived from that function. The third kind of parameter here is that green shaded area, which is the volume under the price curve. And that volume represents, as people are buying the tokens from the contract, the base tokens in the quote token, there's amount of quote tokens which are pooled in the contract. And that's represented by that green shaded area. So when you first launch your curve, if you want some starting price which is greater than 0, there has to be some amount of quote reserve in the contract. And so that first input field there is the amount of quote tokens you're going to send when you create the market and you can see the corresponding starting price based on that volume under the curve. Now, the second thing you see underneath the quote token there is the base token amount. So when you provide that quote reserve, there has to be the initial supply to make the price formula work, right? So at that quote reserve, there's a specific supply, which determines the price. So the three things work together, but you're determining the starting price from that volume under the curve, which is the antiderivative of the price function. So that bottom field is the minimum amount of supply in base tokens that you have to provide, because that's what will be minted back to you given the starting price. It's also important to note that this is the amount of base token that you provide here will determine the limit, the upper limit of the amount of tokens that can be sold from the contract. So there's kind of a lot going on, but the important thing to know is that the amount of quote reserve determines the starting price, and then the bottom field is the amount of base tokens that will be sold from the contract in total. So you can see as you update that quote reserve field, the price will change, and the minimum amount of base token that you need to provide it will also change.
Yep. So to be clear, the amount of quote tokens are like ETH and USDC, USDT. Those are quote tokens. Base tokens are the ERC20. So depending on how much depending on how much quote token you input into Delphi when you start your liquidity pool, determines the starting price of the bonding curve. And if you click here, we'll offer like spreadsheets and more tutorials on how this works and how to see some templates yourself. But basically, this is the value that determines your starting price of the bonding curve. And also a unique thing about Delphi is with the base token, you can input an unlimited amount. So if you want to, you can put in 1 billion tokens, and the bonding curve will just go all the way up till 1 billion tokens are sold as well. And when you're creating a market, yeah, you should be putting you should be thinking about like, how many tokens do I want the total supply of this bonding curve to look like?
Yeah, so that's something important to elaborate a little bit on, because the idea there is because this bonding curve is creating a market for your token, any tokens that exist outside of the contract represent a supply which can be sold on the contract. So that the more supply that exists outside of the contract, the higher likelihood there is of a secondary market, or nothing is stopping anybody from creating a secondary market with the supply that's out of the contract. So for your price model to hold the longest, you would want the most supply in the contract. I'm not sure if it makes sense the way I described it, but yeah, the idea is obviously tokens will be bought from the contract, and that supply will be circulating. But you want to consider the initial supply, what will be circulating outside of the contract and what can be sold from the contract.
Right. Yeah, so that sums up how to create a market. What maybe you want to share, like maybe some insights that you've learned along the way?
Yeah, so this was very challenging. In fact, one of the most, if not the most challenging part of Delphi. This is where we differ significantly from Uniswap or Bancor. In the different versions of Bancor, they have ways of approximating their starting price, but theirs uses a reserve ratio, which doesn't account for this linear slope. So using the linear slope requires some exponentiation, which we do use the Bancor formula for, but we use it in a way that they're not using it. So there were some edge cases. There are many edge cases around that, in particular dealing with the amount of precision that's in your token values, because token values are represented by integers in Solidity, and can have up to 18 decimal places. You're dealing with very, very large numbers, which when passed into the Bancor formula, although Bancor is designed not to overflow or underflow, it can give you weird results that have to do with the precision of the tokens. And so that took quite a bit of test cases and experimentation to figure out. And thanks to the Bancor devs for providing some support to us as well.
Yeah, thanks to the Bancor devs and as well as the Uniswap core team, Dan,
Sure.
and some of our stakeholders in Delphi that made those introductions possible. And cool, yeah, I mean, the idea is that our algorithm on how to determine price is unique from that of Balancer, Uniswap, Bancor, and our hope is that this type of AMM, where people can set the linear growth rate of the price with precision, will cater towards unique use cases that are different from the other DEXs. And at the moment, we're excited to be executing on in the realm of NFTs. And so to provide further light on that, we've launched a few fractionalized NFTs, IDXM and Refraction. Both of these art pieces, they burn the NFT and at the same time mint ERC20s. But internally, we're learning from these launches, we're observing, and we're seeing what sort of is the right way to react to the reaction. Both of these have done great. There's the price for both of them has been stable and close to their all-time highs. And but we're learning a lot, and we needed a few days to observe and learn and collect feedback. But there's a chance we may change our fractionalized NFT contract in the future, depending on how folks are receiving this NFT. So, yeah.
Yeah.
By the way,
to me, I'm sorry.
No, go ahead.
One thing. Yeah, what I noticed, after the launch of the DEX, really, and what we theorized, previous to launch, has come true in the sense that this type of market isn't possible on Uniswap. You can't create such a low liquidity market with, let's say, 100 tokens being issued for, I believe, initial liquidity, let's say on the level of, less than a dozen Ether, right? If that market existed on Uniswap, trades of the size of 1 Ether are going to move the price significantly more, than on Delphi. So for these specific use cases of fractionalized NFTs, where we have, let's say, 100 amount of base tokens, and we want to specifically control the price, there's no other platform that can be done. So that's really cool. And I think it opens up the platform for all these use cases for art tokens and smaller supply tokens, I guess is the way to say it.
Yeah.
But that doesn't mean that we can't launch larger supplies. It just happens to work very well for that use case.
Yeah, so for anyone who doesn't know how Uniswap works with their liquidity pools, the way it works is there's 2 sides of the liquidity pool, or 2 assets in the liquidity pool. There's the quote token, and then there's the base token. And the way it works is that each side needs to be of equal value constantly. And so if people are buying Delphi tokens, and when people are buying, they're putting ETH into the liquidity pool, the Uniswap will calculate the price so that the value of these Delphi tokens will equal the same value of this ETH. And so this is really this is an incredible use case for crowdsourcing liquidity, because the way this incentivizes liquidity providers is, if you look at like just ETH to USDC or something like that, if you're providing liquidity for one of these major pairs on Uniswap, you're collecting trading fees because they charge 0.3% of every trade, and those trading fees are distributed back to everyone that's providing liquidity. And if you do the math on what's the APY on that, you can probably make like 20 or 30% a year on for just providing liquidity on Uniswap. And this is really, really, really convenient because it allows people to earn. Not sure why it's not loading, but it allows people to earn basically yield on their assets with zero directional risk because of the way the 50-50 AMM works. Ethereum can go to the moon, Ethereum can go to zero, or not zero, it could retrace, but you'll still, when you take out your liquidity pool, you'll still have that same amount of value due to the 50-50 fixed ratio. And so everyone asks over and over and over again, like, what makes DAOfi different than Uniswap? I think that Uniswap and Balancer and Bancor, they're both really, really almost as their primary customer type. It's like the liquidity pool provider that they're optimizing and iterating and improving the experience for. And it's like, especially as Uniswap v3, there's segmented liquidity pool. There's that, I forgot what they call it exactly, but allows people to provide liquidity within segmented price range. Like, these are amazing, and it's gonna continue to incentivize this crowdsourced liquidity for crypto. But we're focused on a very different use case, which is, I'm a creator, I'm launching an ERC20 token, or I'm launching a ERC20 that's fractionalized from an NFT, or I'm launching an ERC20 that can be redeemed for an NFT, whatever it is. I'm like launching a small project, and my need is to control the price appreciation, so it doesn't moon out of control, or I know exactly what to expect for my token economy, where I know exactly what the market cap should be based on exactly how many tokens are sold. So that's what you see here. It's like how many tokens people are buying, and you can find exactly the price of the token. And
right. And with Uniswap, you don't have any of that control. The only thing you could do is add more liquidity, and then the more liquidity you add, the slower the price will appreciate, because it will require more trade volume to make that price appreciate. Whereas our price is not a function of volume at all, right? So Uniswap's price function is specifically based on the proportion of amount you put in, based on the amount of reserve that's in the pool. You get a proportional amount out in the other token. Whereas we're not considering proportions at all. We have a function based on supply. And so the price will move on the schedule accurately, regardless of people making very large purchases relative to the liquidity.
Yep. So what you're seeing here with Uniswap, and the price got to like some crazy high price, probably higher than this when it started at a few $100s. Basically, because they have a 50-50 fixed ratio of value going on, and but basically it's causing the asset for the remaining base token in the liquidity pool to continuously kind of cause an exponential price growth in the asset, similar to something like this. So like every time people keep buying Uniswap, it's leaving less and less Uniswap base token in the liquidity pool, causing an exponentially appreciating price. So probably it's trading somewhere up the exponential curve right now, causing the price to do basically price discovery at a very, very, very volatile, in a very, very volatile fashion. So it's Uniswap is convenient for making a market. You could just throw liquidity and get started. But as Alex mentioned, it's a black box on what the price action will look like. It's a little unknown. No one really knows how it works. Like I don't think anyone who made this Uniswap market, even though it says somewhere in here it's like on a bonding curve, I don't think anyone has thought about, okay, like what happens if people buy, or maybe they did, I don't know, but what happens when people buy 100 stocks, 200 stocks, etc.? What's the price action going to look like? But DAOfi is really focusing on making that a step in the process of launching a market. You can completely control it. So that's what we have right now. We have linear parameters for creating a market, and we do plan on potentially, based on user feedback, launching exponential parameters so people can control that. We've done a lot of work on it already, but we decided to ship with linear at first and observe, collect feedback. Everything that we do is in the best effort of iterating, listening to people, improving, making the best effort to make things better. So with every launch we do, with every step forward, we're always trying to just observe and see what out of our hypothesis was wrong, what about in our assumptions was wrong, what could we do to change? Because when we're building such a new product, it turns out like we're like very poor predictors of product market fit in general. So it's a test, hypothesize, test, iterate product processes we have here internally. So yeah.
Yeah, that's good. Let's see. There was one thing I wanted to add. It'll come back to me. Apologies.
Yeah. So just I guess this is a good opportunity to meet the team. Alex has been more full stack plus Solidity. Nathan more on the Solidity side. He wrote also the permit pattern work that we had previously. We decided to shelve that for now, but Nathan is also an auditor as well, and has, if you want to touch base on your experience.
Yeah, I've been around Ethereum for a long time, and I know smart contracts very intimately. So I've worked with auditing teams and have done independent audits as well on anything from something as simple as a token to something more complex like a decentralized exchange, and scalability. As Andrew mentioned, I was working on scalability work here with permitting patterns and side chains. So that kind of work is stuff that I spend a lot of time with. I think we maybe found that it's too much to ask of the user right now to use scalability. The user experience is not quite there yet. So I am focused currently on engineering these NFTs to work in a way to where you can have the price represented with ERC20 tokens being traded on these exchanges. And brought back into the NFT later. So it's a new way of selling NFTs, and I find this quite interesting.
Yeah, I think that it's pretty clear in general that blockchain collectibles, are going to be a really, really, really big market. They're like the way I see the world and like the two assets you can buy, it's either like cash flow producing assets like equities or property, land, buildings. But there's also collectibles as well, which also have intrinsic value for being scarce, for being legitimate, for being authentic, for having consensus from a community that they do have value. And so I think blockchain and crypto lend itself to just an amazing opportunity for digital collectibles to really be so much bigger than what we're seeing now. And so we're just in the early stages of like, how can we experiment with making collectibles more liquid via AMM in a way that makes sense? So it's an iterative process. We only launched 2 art pieces, but we'll be experimenting more models as these art pieces launch and, we evolve. So huge market. I don't think we've even scraped the surface for how big collectibles will be. And the fact that everyone has like tons of dry powder in crypto in their Ethereum wallets and their MetaMask, like they're ready to fire at any given time to speculate, to trade, to yield, farm, to lend, to buy collectibles. And it's all done like on Ethereum with pretty little friction now because everyone has an understanding on how dexes work. It just really feels like this is just seriously like the first inning out of a really, really huge opportunity. But that's where we are. My own separate opinions on collectibles and where we are in crypto. But yeah, Well, thank you. Yeah, any closing thoughts? Anything you want to add?
I remember what I was going to mention, just specifically about the exponential curve functionality. It is something we designed in the contracts which are live now. We just have not determined if it's that useful. Because with very rapid price appreciation, yeah, the use case may be different, and you really have to be sure that that's the right intended price action for that token or that market. And so that's still one of the hypotheses, I guess, that's open. Will exponential curves provide enough benefit to users that we introduce the code there? So.
Yeah, and by exponential value, it just means y equals mx raised to the n. So something like that, where it appreciates exponentially, and right. You can control that. You can control that value, whether it's 2.5 or 3 or 4, or whatever you want. If you want it to be something crazy, you could do that. Right. So that's what we're referring to. Yeah. Well, cool. Thank you. And hopefully it's a good opportunity to meet the team, and open to feedback via all the normal community channels. And yeah, thanks again to the team and everyone watching.
Thank you.
Thank you.
Yeah. Thanks, guys.